In this video, I'd like to discuss the indefinite integral. So, indefinite integral is really the general antiderivative of a function. So, if we have a function, we think of a function whose derivative is the given function, and then we write that class C as the indefinite integral of a function. So that means that if I have a function, then I look for a function for antiderivative of it, and then just class C, which is really the integration constant. So we've discussed in class that as a result of the mean value theorem, if two functions have the same derivative, then they can only differ by a constant. So all of these antiderivatives of this function are included in this setting by allowing C as a constant. So some of the formulas that we came up with is the integral of x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c. This is true for n not equal to minus 1. If n is minus 1, then this is what we get, 1 over x, and its antiderivative, we looked at it in class, is natural log of absolute value of c, absolute value of x plus c. Antiderivative of e to the x is e to the x. Antiderivative of a to the x is a to the x over natural log of a plus c. This is true for a greater than 0 and a not equal to 1. So the integral of 2 to the power of x will be 2 to the power of x over natural log of 2. If you think about it, this is doing backwards. Derivative of a to the power of x was a to the power of x times ln a. So if you're going backwards, you're reversing the process, its antiderivative would be dividing by natural log of a. Then we have the trig functions. Sine x dx is negative cosine of x, and cos x dx, the integral is sine of x. I'm going to put the other ones in right here. Integral of sec squared x dx is tangent of x plus c. Integral of sec x tan x dx is secant of x plus c. Integral of cosec squared x dx is minus cotangent of x. Integral of cosec x cot x dx is cosec minus of cosec x plus c. And we had the inverse trig functions, their derivatives. So this one is sine inverse of x plus c, and this one is tangent inverse of x plus c. So these are the formulas that we built from our derivative rules. Okay, so a couple of properties that I want to discuss are, if you have two functions and you can antidifferentiate each one separately, then you can antidifferentiate the sum of the two functions. So you antidifferentiate the first one, antidifferentiate the second one, and add them. The difference, same thing. A constant multiple of f of x. The antiderivative is the constant multiple of the integral of f of x dx. So these are a couple of properties that we will be using in this process of taking integrals. And so in the next few examples, I will do a couple of videos I'll do some examples on this.